All right, let's practice with some partial fraction decomposition. I want to write this one fraction as the sum of two partial fractions. So I added two fractions together and I got 2x minus 11 over x squared plus x minus 2. My job is to figure out what those two fractions were. Okay, so I'm always going to start by factoring the denominator. If I factor that denominator, I'm going to leave my numerator alone, and I'm looking for two numbers that multiply to negative 2 and add to positive 1. I know that that would have to be 2 and negative 1, so I'm going to rewrite my denominator in factored form as x plus 2 times x minus 1. Then I assume that the two fractions I added together, one of them has x plus 2 on the bottom, the other has x minus 1 on the bottom, and my goal is to figure out what the two numbers were on top. So then again, I'm going to just pretend like I'm adding these two fractions together with a and b on top, and I need my least common denominator of x plus 2 times x minus 1. So when I rewrite these fractions with a least common denominator, the first fraction had the x plus 2 on the bottom. It needs the x minus 1, so I also have to put it on top. For my second fraction, it had the x minus 1 on the bottom. It needs the x plus 2, so I also have to put it on the top. And these two fractions added together still equal 2x minus 11 over x plus 2 times x minus 1. Since all of my denominators are equal now, I can focus solely on the numerators. So I'm going to write 2x minus 11 equals a times x minus 1 plus b times x plus 2. Again, my whole goal in this is to figure out what the a and the b were so that I can go back and rewrite these initial two fractions. I can distribute the a and the b even though I don't know what they are yet. A times x is ax. A times negative 1 is negative 1a. B times x is bx. And b times 2 is 2b. And again, it still equals 2x minus 11. This now is where we group our terms together. So everything with an x gets its own equation, but we do not include the variable x. So instead of 2x, I just write the number 2. Instead of ax, I just write the letter a. And instead of plus bx, I just write the plus b. Then everything without an x also gets an equation. So negative 11 equals negative 1a plus 2b. If I wanted to solve this system for both a and b, it's easiest, I think, to use linear combination. And when I do that, this 1a and negative 1a are already going to go away, so we don't have to do any sort of multiplying in order for a variable to be eliminated. 2 and negative 11 combined together give me negative 9 equals b and 2b give me 3b. Now this is a really easy equation to solve. If I divide both sides by 3, I get that b equals negative 3. Then I can go back and use this initial equation and plug in negative 3 for b. So 2 equals a, and then instead of b, I'm going to put minus 3. If I add 3 on both sides, I then know that 5 equals a. So if I know that negative 3 equals b and 5 equals a, I can substitute those two values back into these two fractions. So instead of a over x plus 2, I'm going to say that one of the fractions was 5 over x plus 2. And instead of b over x minus 1, I'm going to say it was negative 3 over x minus 1. And those are the two fractions that I decomposed, and when I add them together, I should get the 2x minus 11. Let's practice with another one. Again, I'm going to start by factoring the denominator. So two numbers that multiply to negative 48 and add to negative 2. That's a terrible looking 48. Okay. If you think about those two numbers, those should be negative 8 and positive 6. It's always good just to check your work and make sure, because if you make a small mistake at the very beginning with your factoring, it can throw off the whole problem. So negative 8 times 6 is negative 48. Negative 8 plus 6 is negative 2. So then when I rewrite my fraction, I've got x plus 20 over, now in factored form, x minus 8 times x plus 6. And I'm going to assume that when I decompose this one fraction into the two fractions, that it was something over the x minus 8 plus something over the x plus 6. When I add these two fractions together, my least common denominator is x minus 8 times x plus 6. So when I rewrite these two fractions with the LCD, a over x minus 8 needed the x plus 6 on top and bottom, and b over x plus 6 needed the x minus 8 on top and bottom. And it still equals x plus 20 over x minus 8 times x plus 6. Then again, since all of my denominators are the same, I can focus only on the numerators and write x plus 20 equals a times x plus 6 plus b times x minus 8. I'll distribute the a and the b and get ax plus 6a plus bx minus 8b equals x plus 20. From here, I group all of my terms with an x together. I know there's an invisible 1 in front of that x, so instead of writing 1x, I'm just going to write the 1, equals, instead of ax, just the a, and instead of plus bx, just plus b. Then I group all my terms without an x. So 20 equals 6a minus 8b. Here, neither of my variables are going to go away as they are right now. So I'm going to multiply this top equation by positive 8. When I do that, 8 times 1 is 8. 8 times a is 8a. And 8 times b is positive 8b. 20 and 8 combined give me 28. 6a and 8a make 14a. And negative 8b and positive 8b go away, and I wanted that to happen. Then I just have to divide both sides by 14 and get that 2 equals a. I'm going to look back up here at one of my original equations. I can replace this a with the number 2. So if 1 equals 2 plus b, if I get b by itself now, b equals negative 1. So when I rewrite these as their two partial fractions, the a was on top of the x minus 8, and I know now that a equals 2. And b, which I know is negative 1, was on top of the x plus 6. So that's now going to be my denominator. We're going to do one more practice problem together just because it is a little bit different than the previous two. This time when I factor my denominator, x squared plus 6x plus 9, I get x plus 3 times x plus 3. This is called a repeated factor. It's the same factor twice. Another way to think about this is 9x plus 25 over x plus 3 squared. So when I write this as the addition of two fractions, that should be a squared, not a cubed. My first fraction is going to be a over just one of the x plus 3's, and my second fraction is going to be b over the x plus 3 squared. Now I go through the same process. My least common denominator is x plus 3 squared. So for my first fraction, It has one of the x plus 3's, but it needs the other. So that has to go on top and bottom. But my second fraction with the b on top already has the x plus 3 squared. So I don't need to change anything about that second fraction. And I also don't need to change what's on the other side of the equal sign. Now again, since all of my denominators are the same, I focus on the numerators. 9x plus 25 equals a times x plus 3 plus just plain old b. So this time when I'm distributing, I only have to distribute the a. And I know this seems a little bit more complicated at first, but this is actually, in my opinion, one of the easier problems. Now when I group things together, the 9x and the ax are the only two things with an x. So when I write the equations, I know that 9 equals a. I don't have any b term there. Then for my second equation, 25 equals 3a plus b. I already know what a equals, so I can take this value and substitute it in for a. So I would really be writing 25 equals 3 times 9 plus b. I know that 3 times 9 is 27. And then when I get b by itself, I get that negative 2 equals b. So for my two fractions that I wanted, the a was on top of x plus 3, and I now know that a is 9. And b was on top of x plus 3 squared, and I now know that b is negative 2. So these are my final two fractions.